Hi everyone, today we will introduce our conference paper, Toward Privacy-Aware Robot Navigation via Vision Language Models. Privacy is a critical concern in robotics, particularly in public human-shared environments. Consider the scenario where a robot is tasked with delivering a classified document from a manager's office to the HR department. There are multiple paths the robot could take. So how can the robot select the optimal path? 2 points need to be considered. On one hand, the robot may unintentionally expose sensitive information. On the other hand, robots often collect a large amount of sensitive data about users and their surroundings. To address these challenges, we propose an adaptive path planner based on vision language models to protect the privacy. There is the architecture of the Privacy-Aware Navigation Framework. The framework takes a point cloud map as input to generate top view and topological maps, and an optimal path is selected from all potential paths based on the privacy-aware inference of the vision language models. Once the optimal path is selected, the robot can follow the path to complete the navigation task. There is the privacy-aware navigation example, where the selected path by our framework is path 1, even the shortest is path 0, as path 1 avoids high-traffic office areas and takes a route that appears to have less human activity. To obtain the optimal path, we perform 5 independent runs of the VLMs and select the most frequently occurring path as the optimal path. We perform the simulation experiments on S3DIS 3D datasets. We use ROS and the Jackal Robot hardware platform to deploy the privacy-aware navigation in the real world. To evaluate the privacy, we generate a Gaussian modulated distance field for each scene, where higher values correspond to more crowded areas. The results summarized in table shows that our method consistently achieved a lower risk of exposing privacy across all tested areas, indicating a superior capability in maintaining privacy. A case of transporting medicine from an office to a bathroom. We use ROS and the Jackal Robot hardware platform to deploy the privacy-aware navigation in the real world. The robot needs to send a classified file from Office 1 to Office 3. As can be seen, Path 0 is the shortest, but passes through a more crowded office area. Path 1, although it takes a longer route, minimizes exposure to densely populated office areas, ensuring better privacy and security for sensitive files. We use Gmapping with Ouster Lidar to build the grid map of the scene and manually align it with the traversability map, and the navigation stack and follow waypoints ROS packages are used to complete the navigation task following the topological path.